Alright, this is example 2 for conservation of energy problems. A 32 kilogram grocery cart is initially at rest at the start of an aisle. It's pushed by James, who exerts a 10 Newton force 37 degrees below the horizontal on the cart. Use the work energy process to determine the speed of the cart at the end of the aisle, which is 10 meters long. Alright, so the picture in front of you, you have the initial condition. We're going to assume here that the initial velocity is at rest. Alright, our system will be the cart, and the reason I chose the cart by itself, the grocery cart, and not the cart in James, is because we're trying to find the speed of the cart at the end, and the only way that the cart gets speed is if kinetic energy is transferred to it from something from the outside. And in this case, James is going to be doing the work. So our bar chart would look like the following. Initial kinetic energy of 0. Our gravitational potential energy is on the same height, on the same plane, so there's no change in height, so that will also be 0. We'll have ultimately the cart moving, so it's going to have final kinetic energy and no gravitational potential energy. So our equation is going to end up being work is equal to the final kinetic energy. Now in this case, our displacement goes to the right, okay, which I'm going to highlight here in red. So if our displacement goes to the right, when we're trying to figure out the work, we know the work is a force that is parallel to the displacement, and which means I can't use all 10 newtons, I would have to use the horizontal component. So I would have to draw vector components for the 10 newton force exerted on the cart, and then 37 degrees would be this angle here, so the horizontal component would be 10 newtons times cosine of 37. That would be the force multiplied by the 10 meters, that would be the force that is parallel. Alright, and then that ultimately will equal the kinetic energy. So we can substitute all this into our expressions. We have the force, in this case, of James on the cart times the displacement times cosine of the angle between the two is equal to 1/2 mv squared. Alright, so we're looking for the velocity here. We can start substituting numbers in. We have 10 newtons times cosine of 37 times 10 meters is equal to 1/2 times 32 kilograms times v squared. Okay, if we substitute everything in, we get the final speed is equal to 2.24 meters per second. Alright, and that's it.